Now we are going to discuss the article capacitance of a capacitor with the conductor between its plates. Now you can see that I have drawn the capacitor with the capacity C naught, area of the plates A. When there is a nothing between the plates, there is a vacuum or air, and D is the spacing between the plates. So therefore the capacity of capacitor will be A epsilon naught upon D. Now the E naught is the electric field between the plates of the capacitor, and this is given by sigma upon epsilon naught, where sigma is surface charge density. Clear? Now therefore here this is the conductor. Any conductor is placed between the plates, and we know very well that in case of conductor, net electric field is always 0. As the electric field is 0, so therefore electric field exists only in the region as electric field inside the conductor is 0. Therefore electric field exists only in the region in a D minus T, because in region T electric field is 0. In region T electric field is 0, so what is left? D minus T. Okay, using the formula V is equal to E into R, the potential difference between the plates can be written as V is equal to, what is the E? E is E naught. What is the R? R is D minus T. समझ लग गई? So therefore V is equal to E naught D minus T. यही से कहना? E naught D minus T. Now what is the value of E naught? Sigma upon epsilon naught D minus T. And what is sigma? Charge per unit area D minus T. So therefore we got the expression for the V. Now we know C is equal to Q upon V. This is the capacity of the capacitor with, this is the capacity of capacitor with the conductor between the plates. So this capacity is equal to formula, basic concept है C is equal to Q upon V. Now Q, and what is the value of V? We will put the value of V from this equation, and it will be Q upon A epsilon naught D minus T, and Q will be cancelled out. A epsilon naught will move up, it will become D minus T. A epsilon naught D 1 minus T upon D. Now what is this? What is this? A epsilon naught upon D. This is from equation 1, capacitance of the capacitor without dielectric or conductor. So therefore C will become equal to C naught upon 1 minus T upon D. Now therefore you can see that new capacitance is equal to old divided by something, and this is something, this is T upon D, and you can see that T is always less than D. T can never be greater than D. You can see, can that T be greater than D? नहीं हो सकती ना. मैक्सिमम T की हो सकती है, मैक्सिमम T की हो सकती है, बिल्कुल सही, इक्वल टू डी हो सकती है. T can never be greater than D. So therefore here as per the diagram T is smaller than D. So therefore as T is smaller than D, it means from here T upon D is less than 1. So therefore this is less than 1. So anything which is divided by less than 1, it will become more. So therefore capacitance is greater than capacitance of the capacitor without a dielectric. So therefore in both the cases, ਇਹ ਤਾਂ ਚਲੋ ਇਹਦਾ ਫਾਰਮੂਲਾ ਆ ਗਿਆ, ਮੈਂ ਹੁਣ ਕੰਪੈਰੀਜ਼ਨ ਕਰਦਾ ਨੈਕਸਟ ਪੇਜ ਤੇ. Now with conductor, new capacitance is equal to old capacitance. कैसे का फार्मूला? 1 minus T upon D. यही से क्या ना? And for dielectric मैंने याद नहीं है तो ये दसो. C was equal to A epsilon naught upon D minus T plus T upon K. आई से का मेरा ख्याल. It will become A epsilon naught upon D 1 minus T upon D 1 minus 1 upon K. It becomes C naught by 1 minus T upon D 1 minus 1. I think that's not यही है ना, इस तरह से. So this was the formula. This is the expression for capacitance with the dielectric slab, and this is the expression for the capacitance with the conducting slab. And in both the cases you can see C is greater than C naught. Here also denominator is smaller than 1. C is greater than C naught. Now in this case, in both the cases, when T is equal to D, T is equal to D means when the whole space is filled with either dielectric or with the conductor, then what will happen? Let us see here. So it becomes C naught upon 1 minus D upon D 1 upon K is equal to C naught 1 minus d will be cancelled out. Now it will be minus 1 plus 1 upon k, and it will become 1 and 1 will be cancelled out, k C naught. And here in the case of a conductor, what will happen? C is equal to C naught 1 minus d upon d, that is equal to C naught 1 minus 1, that is equal to C naught by 0, and anything by 0 is equal to infinity. So therefore when in the case of a conductor, if this is the plate which is positively charged and this is the negatively charged, now if this whole space is filled with the, we call it a conductor, then what will happen? Its capacity becomes infinity. Why becomes infinity? Because you can give the infinite charge to it to store it. Actually it is not being stored on the capacitor. वो capacitor रहता ही नहीं है. It becomes a simple conductor. Charge will come here, it will pass through the conductor to the negative plate of the battery, and therefore charge will never get stored. Capacitor full होना ही नहीं है. Why? Because it is not storing the charge. Charge is being transferred to the another end. So that is why we say the capacity becomes infinity. Actually the capacitance does not exist. Clear? So therefore in this case we can't fill the plates of a capacitor with conductor completely, but in the case of dielectric we can completely fill it, and depending upon the value of the dielectric constant the capacitance increases. So therefore you must have, if you will read about the capacitors, you must have seen that there are the capacitors filled with mica, paper, wax, oil. Depending upon the situation, depending upon the circumstances, we fill the dielectric of the required value to enhance or to increase the capacity of the given capacitor. So these are the comparison, and this is the comparison, and hence the all about the capacity of dielectric, capacity of a capacitor with dielectric and with the conductor between its plates. This is a question of 3 marks asked in the CBSE exam many times. ठीक है, 3 नंबर ਦੇ ਵਿੱਚ question बहुत बारी आ चुका है. So with this your first unit is complete. ठीक है, तो फर्स्ट यूनिट ਜਿਹੜਾ ਹੈਗਾ ਆਪਣਾ ਹੁਣ